Hello students, so today we will discuss about our third method of factorization, that is using identities. So while solving these types of questions you will be given some polynomials, and you have to rewrite them such that after rewriting them they will form some identity, right? Let us take an example. Suppose here we have to factorize this 9x square plus 24xy plus 16x square 16y square, right? So we can write this 9x square as 3x whole square, and we can write the 16y square as 4y whole square, right? And in the same way we can factorize this 24xy as 2 into 3x into 4y, right? So you can see that 3x can be taken as a and 4y can be taken as b, and if you compare this thing with a plus b whole square, you will get, after factorizing 9x square plus 24xy plus 16y will be 3x plus 4y whole square. So in these types of questions, all you need to do is you need to rewrite the terms so that it matches with any of these three identities, right? So we saw this time about a plus b whole square. Now let us move with solving a question where we will use the identity a minus b whole square. So in the second question you can see that we have been given 16a square minus 40ay plus 25y square. Clearly you can see that 16a square and 16a square can be written as 4a whole square, and this 25y square can be written as 5y whole square, right? And this minus 40ay can be written as minus 2 into 4a into 5y, right? This is 2 into 4 is 8a, 8a into 5y is 40ay minus 40ay, right? So here this 4a will become ra, right? And this 5y will become b. Clearly you can see that here we can use the identity. We can compare this expression that we have rewritten as a 4a minus 5y whole square, right? So in this way, let us see the next question. We are given that we have to factorize 81q square minus 16c square, right? The same manner, this 81q square can be written as 9q whole square, and this 16c square can be written as 4c whole square. Right now it will be written as 9q whole square minus 4c whole square. So we can compare this with the identity a square minus b square, that is we get a plus b into a minus b, right? If you write this 9q whole square minus 4c whole square, you can rewrite this as 9q plus 4c into 9q minus 4c. So this is the required factorization. Let's suppose that in some questions, if you cannot find the square root of any given number, just try to divide it by number 2 or 3, right? Let us take question number 4. And this we are given that we have to factorize 25x square minus 30xy plus 9y square minus 121. So we will break this equation into two parts. That is, first one is 25x square right? First we will break it in 25x square plus minus 30xy plus 9y square and minus 121. Why are we doing this? It's just because when you factorize this 25x square minus 30xy plus 9y first, what you will get is 5x minus 3y whole square, right? See how this 25x square can be written as 5x whole square minus 30xy can be written as 2 into minus 2 into 5x into 3y. This 9y square can be written as 3y whole square. So this will become 5x minus 3y whole square. Now you can see that 121 is the square root of 11, right? Now we will use our third identity, that is a square minus b square, where we will consider 5x minus 3y as a and 11 as our b. If we consider them, then what we will get is 5x minus 3y plus 11 into 5x minus 3y minus 11, right? So this is our required factorization. So in this way you can uh, factorize the given polynomial using identities. Now next moving on to our fourth method, that is factorization using middle term splitting. This method is very widely used in higher studies also, so this method is little bit important. So suppose that we are given, we have to factorize this 3x square plus 8x plus 5, right? So what we have to do is, first we will multiply this 3x square with 5, right? So what we will get is 15x square, right? Keep this thing one side. Now we have to break this 8x in such a way that when we multiply those two terms, the result we get will be equal to this 15x square, right? Let's see how it can be done. So this 8x has to be broken, right? So we can write this as x plus 7x, right? And we can also write it as 2x plus 7x, right? So like this, there are infinite number of ways in which we can break this 8x. But you can see that if we multiply this 2x with this 7x, we are not getting 15x square, right? So we will select those two terms of 8x after breaking, which will multiply to get 15x square, right? So we can also break this 8x as 3x plus 5x, right? Clearly you can see that we can multiply them to get 15x square. So this 8x can be written as 3x plus 5x. Now as you can see, we have written this 8x as 3x plus 5x. Now again comes our first method, that is taking out the common factors. But how will you take the common factors, right? First of all, you will make the pairs, right? So I'm making here 3x square plus 3x one pair and 5x plus 5 as another pair. Now from the first pair, clearly we can take 3x common, right? So if we take 3x common, what we will be left is with x plus 1, right? And in the same way, we can take 5 common from the second expression, right? If we take 5 common, what we will be left is with x plus 1. Now again, if I consider these two terms, first one is this, second one is this, right? We can take this x plus 1 common from both of them, that if we can take x plus 1 common from both of them. So after taking this x plus 1 common from both of them, let's see, we have taken x plus 1 common from both of them. What we are left with in the first expression or first term is 3x, right? This 3x, we are left with this. uh, and in the second term, if we take x plus 1 common, we will be left with this plus 5. So this is plus 5. So this is our required factorization, that is x plus 1 into 3x plus 5. Right, let us move on to next example. See, while doing middle term factorization, all you have to do is first you have to multiply the first term with last term, and then you have to split the middle term in such a manner that after splitting the middle term into two parts, when you split the middle terms in two parts, the product of those two parts should be equal to the product of first and last term, right? So suppose in this again, if you multiply this 3x square with 4, what you will get is 12x square, right? You will get 12x square. Now you have to break this 13x, right? So this 13x can be written as 12x plus x. Again, you can see that if you add them, you will get 13x, but when you multiply them, this 12x with x, you will get is 12x square. So this 13x can be written as 12x plus x. Now again, we will make the pairs. We will take the common, and that will be your required factorization, right? In this manner, you can solve any question where middle term splitting is required. So in the next video, we will be discussing about the division of algebraic expressions.